so let's take a look at 19. 19 said that we have the square root of 3n times the square root of 24n. Is this the one you're talking about?
Yeah.
Okay. So all of you are taking notes on this if you didn't have this right. We are multiplying radicals. So what that means is everything right here is under a radical. I have two radicals being multiplied together. So I'm going to go ahead and put them underneath all the same radical symbol. So I have 3 times 24 times n times n. The stuff I'm showing you is the stuff you should have. Do you guys understand that? Everything I'm showing you should be the steps that you have. Yes? I haven't even finished doing anything yet.
I have a question.
Okay. I am going to enjoy my next line, sure. All right, so off to the side, I'm going to do 24 times 3. I think is 72. So I have 72 times n squared. All right, now from here, Victoria, what are you doing? No, I already told you you're not doing your notes right now. Right now, you were taking the answers down. Once you waited, once you were done with that, I don't have a problem with taking notes. Now, you're doing the stuff we're doing because I'm teaching it to you right now. All right, so now, 72. What perfect square factor does 72 have? Blythe? 9 times 8. So I'm going to break this up into the square root of 9 times the square root of 8 times the square root of n squared. Questions? Yes. Colin, I already told you yesterday you could do whatever perfect square. So that should not be a question. You can do any perfect square that is a factor. You know what I mean? Remember I was talking about that yesterday? Yes. All right, so from here, I'm going to finish this up. The square root of 9 is 3. I've applied that. The square root of n squared is n. Now I'm going to look at my 8. Blythe, does 8 have a perfect square factor? What? 4. So I'm going to break that square root of 8 into the square root of 4 times the square root of 2. Now I'm going to keep going. I have 3 times, well, the square root of 4 is 2, so I have 3 times 2 times 9. And then the square root of 2, that's as simple as that can go, so I'm just going to write times the square root of 2. And now I'm going to multiply. 3 times 2 is 6 times n times the square root of 2. Remember, I just have to use any perfect square factor of the number. Some of these will only have 1, like 8. Some of them, like 72, will have more. You just need to use a perfect square factor. You may have just said 72 is divisible by 4. All right, and you could use 4. It's just longer. You have more steps to do, but you could have used 4 as well. One of them has to be a perfect square. All right, what else can I do? Questions on this problem? Jack, are you cool with this? Or do you guys have any other questions on last night's homework? Okay, get your notes out. Okay, so now what we're going to do is we are now moving into when we have fractions in our radicals. So today is 1023. We are looking at Chapter 11, Section 1, continued. Simplify radicals. Okay. So what we're going to be focusing on now is when we have fractions with radicals. Yesterday we talked about when we are multiplying radicals, This really is when we are dividing radicals. That's really what fractions are, is when we're dividing radicals. All right, you guys cool so far? Okay. Here's the deal. We do not want a radical in the denominator. That's the first thing. So when we talk about simplifying, we do not want a radical in the denominator. Everyone's in pencil, in their notes, please. Jack, is that a pencil or pen, please? Awesome. You can highlight stuff in pen, but write in pencil for me, please. And the other thing is the numerator radical must be simplified. So these right now are going to be our goals. Please take very good notes on this. All right, because I'm going to be asking you guys a lot of questions along the way to have our thinking process moving along. Who needs to see what's up there? All right, remember, there's two things for it to be simplified. There's no radical in the denominator. And your numerator, if there's a radical in it, it's simplified. All right, so let's just go ahead and do an example. I'm going to do an example to the left, and I'm going to say some steps or comments to the right. All right, so if I have in one big square root symbol, the fraction 11 over 49. What do you notice about 49? What do you notice about 49? Isabel? It's a perfect square. So you need to use your observational skills here. That 49 is a perfect square. So I'm going to say here, since denominator is a perfect square, split the radical symbol between the numerator and denominator. All right, so I'm going to go ahead and do that. I have the square root of 11 over the square root of 49. What is the square root of 49? Nick? 7. So my denominator is now a 7. Does 11 have a perfect square factor? Does 11 have, keep the chair down please, Serena. Does 11 have a perfect square factor? Serena? No. So that square root of 11 is simplified. You guys cool with that? Okay, let's do another one. Yeah, it's simplified. We're done. We got rid of our denominator radical, right? Our numerator is simplified as far as it can go. We're done. Okay, let's take a look at another one. Let's say I have the square root of 25 over b to the 4th. All right, remember, I want you guys rewriting those variables as b squareds. So if I was to rewrite this as b squareds, I have b to the 4th is going to be b squared times b squared. Well, what do I know about b squared? What do I know about b squared? Colin? What do I know about b squared? Why does it equal b? What do we know about b squared? What do we know about b squared? Those are all correct answers. That's not what I'm wondering. It's the same thing I said to you of when I said, what do I know about 49? What do I know? It's a perfect square. So I'm going to rewrite this, and I'm going to rewrite this as the square root of 25 over the square root of b squared times the square root of b squared. Now simplify. All right. What's the square root of 25? Sam? 5. What's the square root of b squared again, Sam? B. I have 2 of those. So what's my final answer, Sam? What's my final answer? 5 over b squared. What do you guys think? You guys go with that? All right. I'm going to give you 3 of them that I want you guys to do. Okay? Who needs to see what's up there? Are there any questions? Sam? Well, we're going to talk about that tomorrow. So I don't want to throw too many things at you all at once with these radicals because they can get confusing. All right, we have 3 more radicals, 2 more radicals after this that we're going to be doing, types of radicals and processes, okay? So I just want to take one at a time. All right, let's flip, and let me give you a couple of them. Nick, what's up? B squared. I want you showing me what b times b is.
No, I know that, but
Okay.
you have to make it b squared.
I want you to tell me what b times b is. I just said that.
Alright.
And then you said to me, yeah, I know. But then you asked me the same question. Do you know that you did that? You said to me, I have b times b. You said b times b. I said, yes, you have to write that. You have to tell me what b times b is. You said, yeah, I know. And then you said to me, can I just leave it as b times b? Am I getting marked down? Do you know that I answered your question the first time? I'm just wondering if you knew that.
I do now.
Okay.
I know you do. I was just
Okay.
or like I felt like I knew.
Okay. So yes, I want to know what b times b is. Okay. All right. So this is the first one. I want you guys to simplify. done, check with someone sitting by you. Well, I would start immediately with 4 and see if 4 will work, because that's the easiest one. And if 4 will work, maybe try 16. But you guys don't have a calculator, so maybe 4 is the easier one to start with, because then you can kind of do more steps involved, but you can divide 4 easily. So see if 4 does. Questions? Have someone help you next to you. Walk it through with somebody. If you're struggling, help each other. That's part of what I expect you to be doing, is helping each other. So if you are really good at this, then find somebody near you that's not and help them. Yes. Yep. And by the way, that's a cue. I'm so sorry. I'm so sorry. This is a cue. Does that make more sense, you guys?
Yeah.
I'm so sorry. That's a cue. Not a 9. Thank you for asking that. I'm glad you guys are paying attention to that. That is a cue. If that was square root of 9 squared, it would just be 9. Because the square undoes the square root, right? So yeah, that would have been. Yeah, that could have been. But I meant that to be a cue. You do. Yeah, so a square undoes a square root, so if you would use 9 or use a 9, you just would have done it. Yeah, yep. All right, so let's walk through this. Who's still working? All right, let's walk through this. And if you're not done, we can catch up. You can catch up to us. So let's look at that first one. I have the square root of 144b squared over 9b to the 8th. Okay. How many of you, and if you didn't, that's okay, how many of you thought about dividing out common factors with your b's? You could have. You definitely could have. You have a b squared in the numerator. You've got b squared, you've got b to the 8 in the denominator, so you could use your division, dividing two numbers with the same base. Keep the base, subtract the exponents. I wouldn't have necessarily thought that I wouldn't expect you guys to do that, but if you thought about it, that's okay. But the way that we are doing it, I'm going to go ahead and break this up. I have the square of 144 times the square root of b squared in my numerator. I have the square root of 9 in my denominator. Now the reason I can break 8 up, that's b to the 8th is because I have an even number of b squareds. If that was a 9, this is a different type of problem. That's what we're going to be doing tomorrow. But since that's an even exponent, I know that I'm going to have a bunch of b squareds. Thank you for helping me. So I have 9 times the square root of b squared 4 times. So now I'm just going to apply my square roots to everything that's a perfect square. So what is the square root of 44? Sam? 12. Peter, what's the square root of b squared? Excellent. There's my numerator. Denominator, what's the square root of 9? Kellen? 3. And then we have 4 square roots of b squareds, which are all b's. Okay. So I have 12. Well, I'm going to leave it like that for now. What do you notice about our numerator? What do you notice about our denominator? Ashton? Yes. So at this point, I want you DOCF. I want you dividing out common factors. So before you even turn that into b to the 4th, I can automatically see one of my b's cancel out for my numerator in the denominator, and the 3 cancels out in the 12 and the 3. So my final answer is going to be 4 over b cubed, because I can divide out common factors. How many of you guys noticed that? How many of you guys are like, oh, totally, now I see that? Okay, so DOCF whenever you can. Once you're done, you cannot DOCF a number outside the radical with a number inside. So it can only be the numbers outside for now. Okay, let's look at the second one. I have the square root of 25p cubed over q, squared. Somebody tell me what to do here. Serena, go ahead, bud. Don't I want them in square roots? Okay, they have to be in a square root. Are you showing yours in a square root? Oh, well then you didn't do the problem right. Because it's all in a square root. So I have to see the square root of 25 times the square root of p squared times the square root of p. That's the whole problem, dude. They're all square roots, man. Can't forget those. And then my denominator is going to look like p square root of q squared. Now someone finish this off for me. Jacob?
So you would square root of 25 is 5.
Okay.
And then times, so p squared would be p times p would be p squared.
No. I do agree with you, the square root of p squared is p. But isn't this the square root of p?
Oh, yeah.
I have to leave that inside, that square root symbol. Does that make sense? Awesome. Excellent. And we are done. Questions on that one? All right, let's look at, so this is my first one. Here's my second one. All right, let's look at my third one. I had 96 over 36t squared. 36t squared. Okay. Somebody tell me what to do here. Hello? Hi. Come on. Someone tell me what to do here. Ashton. It was up for a little while. All right, so let's just start. We'll work on it together if you have troubles. What's the first step, Ashton? Okay, so I need to do the square root of 96 over the square root of 36 times the square root of t squared, correct? Yes? Okay, and you said 96 is what? So this is going to be the square root of 4 times the square root of 16? Is 96 a perfect square? It is? Wow, how nice of me. Is 96 really a perfect square? No, it's not. So it cannot be the multiple of two perfect squares. That's not possible. So 96 divided by 4 is 24. Did you do 90? Were you looking to do 4? Were you looking to do 4 or were you looking to do 16 as your factor? 4. So this is 24. You could have done 16. You could have done 16. It's 16 times 6. However, if you saw 4 without a calculator, sometimes finding these perfect square factors can be a little bit more challenging. If you know for sure 4 is, use 4. All right? Okay. So, what's the square root of 36, Ashton? 6. And then what's the square root of t squared? Excellent. So my denominator is done. So what's the square root of 4? 2. Can 24 be broken up into a perfect square factor? What is it? Square root of 4 times, all right, over 6t. All right, what is, so I have 2 times. What's the square root of 4? 2. All right, so I end up with 4 times the square root of 6 over 6t. All right, so I'm going to stop right there for a second. Can I divide out common factors between the 6 in the numerator and the 6 in the denominator? Can I divide out common factors between the 6 in the numerator and the 6 in the denominator? And you have to tell me why or why not. Charlotte? You do. So here's the thing. So I'm going to put a little note here. Can not DOCF between square root of 6 and 6. Because the square root of 6 is in a square root symbol. However, can I divide out common factors in this one between any of the numbers to simplify it? Victoria, which ones? Yeah, I can divide out common factors between these because they are both outside the radical. So I'm going to say DOCF because both are outside the radicals. So when I do that, the 4 becomes a 2, the 6 becomes a 3. So my final answer is going to be 2 times the square root of 6 over 3t. What do you guys think? You guys okay with this? All right, so tonight, luckily, the ones you should be doing tonight should all have perfect squares in some way in the denominator. Tomorrow night is going to be a little bit more challenging. All right, you guys cool? All right, you guys can go.